gas law. So, you kind of look at that first word and it kind of tells you quite a story there. I mean, it's combining the gas laws that we've learned up to this point. Hey, hey, hey. All right, so we're going to talk about how pressure, volume, and temperature all kind of fit together when we're talking about gases. Okay, a lot of this video, so I don't have animations for this. It's really just kind of looking at what we've already done, putting it all together, and using the formula that we have to do calculations. Alright, so first of all, what is the formula for this law? So I think that from experience, from what I've seen, it's really kind of confusing for a lot of you guys if I sit here and try to show you how this formula kind of came about. But let me just give you a hint if you want to kind of if you want to try it on your own to derive it. You're going to multiply Boyle's law times Charles' law times Gay-Lussac's law. Okay, you're going to multiply those three together, and then you're going to take the square root. Alright, so I know that you can kind of rewind and kind of hear that again if you want to try to derive it yourself. But kind of other than that, I'm kind of just going to write it out here for you. Okay, so we're going to call it V1 P1 over T1 equals V2 P2 over T2. And out of all of the laws, this is the one that I remember the easiest, probably, besides the ideal gas law, because I've used that one so much. But I've remembered this for a long time. I'm pretty sure it was my high school chemistry teacher that said that we could remember this using vice president over treasurer. So that's how I usually remember it. So vice president over treasurer, and that's how I try to remember it. Obviously, that's volume 1 times pressure 1 divided by temperature 1 equals volume 2 times pressure 2 divided by temperature 2. And before we kind of go off and do the two problems that I have set out for this presentation, for this video here, I just want to kind of mention that you can use this formula. Alright, so I can use this combined gas law formula to solve a Boyle's law problem, to do a Charles law problem, and to do a Gay-Lussac's problem. Alright, all I have to do is whatever they don't mention or whatever they're holding constant, I just eliminate from my problem. So for example, alright, so I have my V1 P1 over T1 equals V2 P2 over T2. What happens if I hold my temperature constant? Alright, well if I hold my temperature constant and I just kind of say that I'm going to get rid of it or make it 1, alright, so I'm just going to make that 1. So I just am going to have V1 times P1 equals V2 times P2. Well, what is that? That's Boyle's law. And lo and behold, alright, Boyle's law, the temperature is held constant. Okay, so I can use the combined gas law to solve all three types of problems, and you can kind of try to work that out for how that works for Charles' law and Gay-Lussac's law as well. Excuse me. Kind of feeling like I might lose my voice again, which, gosh, please don't let that happen. Alright, so let's move along here into our first problem. So we're going to solve these just like I've done any of these other problems, okay? So it's using those same methods. It's only thing that really changes is that I'm using a different formula, okay? So in this case, it talks about having 430 millimeters of mercury, okay? So the first thing I'm going to do is I'm going to say, what do I have? Okay, this should be sounding, if you're watching these videos, and especially if you're watching them one after the other, this should start sounding really repetitive to you, and if it's not, I'm a little scared for you. Alright, so what do you have? Alright, well the first thing that they give me is a pressure. You need to recognize that millimeters of mercury is a pressure. So I'm going to say that's my pressure 1, 430 millimeters of mercury. Now I'm going to kind of ask myself, do I have any, do I have a volume or a temperature that goes with that? And right here, they give me a temperature in degrees Celsius of 20. So they gave me 20 degrees Celsius. Then I'm going to ask myself, well, is there a volume that goes with it? And Looky here, there is. All right, they say has a volume of 2,100 milliliters. So I'm going to put 2,100 milliliters. So I'm going to switch colors here just so you can see that this is my second condition. So I'm going to make some changes to my system here. So I have what is the final pressure. Okay, so that means I don't know my pressure. I don't know my pressure too. It's asking me what it is. I don't know it. All right, at a volume of 1,250 milliliters. So that's my second volume. Okay, and a temperature of 175 degrees Celsius. So that would be my second temperature. Awesome. So after that, I'm going to ask myself, do I have any conversions? Well, do I have any conversions? Well, I don't really need to convert my milliliters because they're both the same unit here. Okay, I'm not going to worry about my pressure over here either. But this right here should be screaming at you. If you wrote, I was writing this down, if things weren't going in your head like, what degrees Celsius, you need to rethink some of these problems here. All right, so when I'm talking about my conversions, I'm gonna do blue here. When I'm doing my conversions, I need to convert my degrees Celsius here. All right, so I need to add 273 to it to make it 293 degrees Celsius, and to my temperature 2, gonna add 273 degrees Celsius. Okay, so that's what, 8. There's a 4. My foot's kind of stuck on this stool, so I'm a little bit stressed out about that. All right, and that's not degrees Celsius. Fail, Mr. Neiman, fail. All right. So my temperature 1's 293 Kelvin, and my temperature 2 is 448 Kelvin. Okay, so now what I'm going to do is I'm going to say let's rearrange our equation. Okay, let's rearrange this bad boy here. And so my initial equation is V1 times P1 over T1 equals V2 times P2 over T2. All right. And I'm going to rearrange that to get whatever I need to solve for by itself. So I need to get P2 by itself. Okay. And to get P2 by itself, what I'm going to do is first I'm going to multiply by T2. Okay, so that gets rid of my T2. Now that's over there. Okay, and kind of just in the spirit of not having everything super cluttered, I'm going to say V1 P1 times T2 over T1 equals V2 times P2. I still need to solve for my P2. Okay, since I'm multiplying it by my V2 here, I need to divide, need to do my inverse operation. Alright, so I need to divide this side. Wait, not by P2. I'm trying to get P2 by itself. By V2, so I'm going to divide this side by V2, and I'm going to do the same thing on this side. So what I'm left with is V1 times P1 times T2 divided by T1 times V2 equals P2. Okay, so that's kind of what I'm left over with. And what you kind of see is that you had your P2 here. I pretty much just multiplied by the reciprocal. So I just put T2 on top and my V2 on bottom. If the word reciprocal doesn't make sense to you, just ignore me. Alright? So now what I'm going to say is let's plug in, and calculate. Alright, so my volume 1 was 2,100 milliliters. My volume 2 was, or my pressure 1 was 430 millimeters of mercury. My temperature 2 was 448 Kelvin. I'm just going to say that P2 is that, right? Because I don't have room to write P2. So my temperature 1 is 293 Kelvin. And my volume 2 is 1,250 milliliters. So now when I kind of cross out my units, my milliliters cancel. My Kelvin cancels. I'm left with millimeters of mercury. That's kind of a hint that, hey, I'm left with the pressure, which is what I kind of should have, right? So then I'm going to just do it in my calculator. So 2,100 times 430 times 448. And then I'm going to divide that by whatever 293 times 1250 is. And I am going to get my pressure 2 as 1,100. Okay, 1,100 millimeters of mercury. So I'm going to get when I put it in my calculator. Alright, so that's pretty much how you solve one of these problems, and I'm going to do one more, and hopefully I don't have to cut it off or try to edit anything out because these videos can only be 15 minutes. But here's all the work, and remember you can pause and go back and do whatever you need to do to get everything that I talked about. So the last problem is a diver exhales a bubble with a volume of 300 milliliters. So just like with all these other steps, I'm going to say, hey, what do I have? Well, I have a volume of 300 milliliters. Okay, my pressure one is going to be 3.6 atmospheres. And it gives me a temperature of 10 degrees Celsius, and that should scream at you. Alright, that should be screaming out at you. And then it says, what is the volume? What is the volume? That means that's what I don't know. Okay, what is the volume of the bubble when it reaches the surface where the pressure is 1 atmosphere and the temperature is 25 degrees Celsius? Okay, once again, those should be screaming out at you, those degrees Celsius there. Okay, so my second step, I'm going to say, what are my conversions? Well, once again, I'm only going to have to do my degrees Celsius. Okay, so my temperature 10 degrees Celsius plus 273, okay, is going to be 283 Kelvin. Okay, and 25 degrees Celsius plus 273 is going to be 298 Kelvin. Okay, so now I'm going to move down here and I'm going to rearrange my equation again. Okay, so I have my vice president over treasurer equals vice president over treasurer. Okay, so to rearrange this, I'm going to just do something similar to what I did last time. So hopefully, or kind of the shorter way to say this, but here I have my volume 2. Okay, so that's what I'm solving for. So what I'm going to do here is I'm going to take this part right here, and I'm going to flip it. I'm going to multiply by the reciprocal. So I'm going to multiply by it flipped. Alright, and so what that does is that crosses out my temperature and my T2 and my P2. But if I do that to this side, to my right side, I also have to do it to my left side. Okay, so for my final formula to solve for V2 here, I have V2 equals, okay, V1 times P1 times T2 over T1 times P2. Okay, so at that point I just have to plug everything in and calculate, and I have 300 milliliters times 3.6 atmospheres times my temperature 2, which is 298 Kelvin. Okay, and I'm going to divide that here by my temperature 1, which was 283 Kelvin, times my pressure 2, which is 1 atmosphere. I'm going to look at my units. Atmospheres cancel, kelvins cancel. I'm left with milliliters, which is a volume unit. So I am looking good. I am looking good. I'm just ready to go out and have some fun with some chemistry. Alright, so I'm going to multiply across the top. Then I'm going to divide by 283 times 1. And I am going to be left with a wonderful volume here of 1,137, and significant digits, I'm going to say that, I don't know if I put a dot there, but, or I'm just going to say that we have 2 significant figures here, so we'll say that I have 1,100 milliliters. Okay, so that's it for combined gas law. So this should be the 5th video of the gas law series, and I will be doing the ideal gas law next, and then following that with gas stoichiometry, and that will probably be it for this unit. And that's really most of what you need for the test.